Which form of the equation of a plane that we like working with? It was z equals what? Remember? Plus what? Minus x naught and oh, not y. Sorry, it was y. Thank you. And yep, y minus. And this was, we now know that was just fx, right? And that was what? Fy. Exactly. So on number 2, we had a bid for number 2. It was z is equal to y e to the what? X over y. And what was the point? 1, 1 e. So you need to first find fx. So you're differentiating with respect to x. You treat everything as a constant except for what? X. Everything is a constant except for x, right? So the derivative of e to the x over y is just going to be e to the x over y times 1 over y. So 1 over y kicks out, but then you also have the same thing again, right? What cancels? So you end up with what? E to the x over y. So you need fx at what point? 1, 1 e. Do we need to plug anything in at this point?
No, isn't it just 1, 1? Isn't it just 1, 1?
I'm asking you. Yes, it is just 1. Got it. So you do plug in 1. What do you plug? Do you plug in 1 and 1 or 1? What do you plug in?
1.
1 for x and 1 for
y.
Yes, you need a number is what I'm trying to get at. So you end up with e to the 1 over 1, which is e. So then you need fy. What's that going to be? Well, this is a little different because what do you have to use?
Product rule.
Product rules. You're dictating rule here, right? And you have to use the chain because it's going to be inverted, right? So what you're doing, just to write it out if you want to actually see it, z is equal to y times, careful, e to the x times 1 over y. That might help you see it a little better if you're going to do the product rule on this. So what's fy going to be? The derivative of the first times the second plus the first times the derivative of the second. What's the derivative of the second going to be? X, because that's the derivative of the top. Is that plug anything else out in front? I know, I'm not done. I'm just saying this. Here's the derivative of that. That stays there. So now we have the first times the derivative of the second, which it's going to be e to the x over y, correct, times the derivative of
X
times the derivative of, sorry, the derivative of this in terms of when you're taking the derivative with respect to y. So what's that going to be?
Negative 1 over x over y.
It's hard to think of. It's like a brain teaser. It's like
1 over x to y.
yeah, so you're doing this. Like, it's easier to see if you had this, like, what's the derivative of that, right? No, I'm serious. When your brain looks at that, you're like, oh, well, that's 7 times x to the negative 1, right? So the derivative of that's going to be negative 7x to the... We have the exact same thing, except what are we doing? We're doing x is the 7 and y is the x, right? So what do you end up with? You end up with negative x, y to the negative 2. It's interesting. It's like, you ever seen those brain teasers where it's like a blue background and the word blue but is written in green, and you have to like say it, and it's just really hard to do? So at this point now, what do we plug in? At least we're doing... Oh, do you want to simplify first? No, I think that's a very good thing to do. If we can simplify, absolutely. What can we simplify here? This gets rid of this, right? But it still stays what? Minus 1. Does anything else cancel? Not so much. Doesn't look like. So f of y, 1, 1, what's that going to be? E plus e times negative 1 times what? 1?
Yeah.
So what do we end up with?
0.
Is it 0? It's decent, right? So we have our formula right there, which is this, right? So then you just plug it in, right?
Yeah.
So when we do this, when we plug these things in, what's our point? Our point's kind of nice. 1, 1 e, right? So what's z going to be? E plus, what was fx? E times x minus 1 plus
0
times y minus 1. But what goes away here? That goes away.
And then
Z is equal to e plus e times...
no, ex minus e.
Oh, I know. I'm just writing it out step. I just sometimes like to overwrite. So say ex minus what? That goes away. You're left with z is equal to ex. That's kind of cool.